The Theory of Quantum Electrodynamics. Charged Particles. Richard Phillips Feynman. 1918–1988. Photons are what we know as light with no charge and no mass. Electrons are negatively charged, kind of cloudy and wavy fields around the core of the atom. Positrons are positively charged reflections of electrons. We don't have positrons in our ordinary universe. However, particle accelerators can create positrons for tiny nanoseconds and tiny nano quantities. Electrodynamics explains the interactions between charged particles in motion and magnetic fields. Its principles describe the phenomenon of magnetism, radiation, and induction. Quantum electrodynamics describes the interactions between the photons, electrons, positrons, and electromagnetic fields as well as other particles. Particles can emit and absorb photons which affect the behavior of the particles. For instance, 145 nanometers wavelength photons are absorbed by oxygen molecules. They split the oxygen molecules into oxygen atoms. Feynman's basic actions. A photon goes from one place in time to another place in time. An electron goes from one place in time to another place in time. An electron emits or absorbs a photon at a certain place in time. A wavy line for the photon, a straight line for the electron, and a junction of two straight lines and a wavy one for a vertex, representing the emission or absorption of a photon by an electron. A probability amplitude is a wave function that describes the position of an unknown quantity. The probability is the square of the total probability amplitude value. The behavior of the photon or electron moving from one place in time to another place in time depends on their momentum and polarization. The bare charge of the electron is the quantity that tells us about the probability amplitude for an electron to emit or absorb a photon. This is not the same as the measured electron charge. Quantum electrodynamics is the calculation of the probability of the complex interactions between many electrons and photons by using probability amplitude that is compatible with Feynman's basic actions. There is a possibility that the electron might move to a place in time E before emitting a photon. There it absorbs a photon, then first moves to F and next scatters to C where it is detected while the photon scatters to D. The probability can be calculated by probability amplitudes of 3 electron actions, 2 photon actions, 2 vertexes, 1 photon emission, and 1 photon absorption. There is another possibility that the electron moves to G where it emits a photon that goes to D while the electron moves to H where it absorbs another photon before moving on to C. The probability amplitude of an electron at a specific position, or a photon at another position, moving as a basic action to any other place in time in the universe is non-zero even if target places or earlier times require speeds greater than that of light. An electron moving backward in time can be viewed as a positron moving forward in time. We can calculate the probability of charged particles by using probability amplitude with high accuracy. However, calculations still fail to explain why charged particles have masses or mathematical numbers. Feynman, there is no theory that adequately explains these numbers. We use numbers in all our theories, but we don't understand what they are, or where they come from. I believe that from a fundamental point of view, this is a very interesting and serious problem.